Since the dawn of military aviation, speed has been a crucial factor in gaining an advantage over the enemy. World War I biplanes engaged in dogfights at speeds barely exceeding 100 miles per hour. By World War II, fighters like the P-51 Mustang and the Messerschmitt Bf-109 were reaching speeds approaching 400 miles per hour, thanks to powerful piston engines and aerodynamic advancements. However, the quest for even greater speed was far from over. The limitations of propeller-driven aircraft were becoming increasingly apparent. As aircraft approached the speed of sound, propellers encountered a phenomenon known as wave drag, which significantly hindered further acceleration. The solution lay in a revolutionary new technology, the jet engine. The development of jet engines during World War II promised a new era of high-speed flight. Early jet fighters like the German Messerschmitt Me-262 hinted at the potential of this technology, but it was in the post-war years that jet aircraft truly came into their own.
The end of World War II marked the beginning of the jet age in earnest. Military powers around the world raced to develop and deploy jet-powered fighters, eager to harness the potential of this game-changing technology. The United States, the Soviet Union, Great Britain, and others invested heavily in jet aircraft research and development. One of the most iconic aircraft of this era was the Bell X-1, a rocket-powered experimental aircraft developed by the United States Air Force. On October 14, 1947, Captain Chuck Yeager piloted the X-1 to a speed of Mach 1.06, becoming the first person to break the sound barrier in level flight. This achievement was a watershed moment in aviation history. It not only proved that supersonic flight was possible, but also opened up a new realm of possibilities for aircraft design and performance.
The sound barrier, once considered an insurmountable obstacle, had been broken. Now, engineers and pilots alike focused on pushing the limits of supersonic flight even further. The next challenge was to design aircraft that could not only achieve supersonic speeds, but also maneuver and fight effectively in this new realm. Early jet fighters, while revolutionary in their speed capabilities, were often plagued by stability and control issues at high speeds. Pilots had to adapt to the unique challenges of supersonic flight, including shock waves, transonic buffeting, and the significantly reduced reaction time required for decision-making. New aerodynamic concepts such as swept wings and area ruling were developed to address these issues. Swept wings help to delay the onset of shock waves, while area ruling, also known as the Coke bottle design, reduced transonic drag by smoothing out the airflow over the aircraft.
The advent of jet fighters transformed the nature of air combat. Dogfights were no longer slow, turning engagements but rather high-speed dashes, where split-second decisions could mean the difference between victory and defeat. The Korean War, from 1950 to 1953, provided the first major testing ground for jet fighters in combat. American F-86 Sabres faced off against Soviet-built MiG-15s in intense air battles over the skies of Korea. These engagements highlighted the importance of pilot skill, aircraft performance, and tactics in this new era of aerial warfare. The MiG-15 in particular proved to be a formidable opponent. Its powerful engine and high climb rate gave it an edge in many engagements. The F-86, however, benefited from superior maneuverability and a sophisticated gun sight, allowing its pilots to score a favorable kill ratio against the MiG-15.
Beyond the speed of sound, reconnaissance and surveillance. The impact of jet propulsion extended beyond air-to-air combat. The ability to reach high speeds and altitudes made jet aircraft ideally suited for reconnaissance and surveillance missions. High-speed reconnaissance aircraft could penetrate enemy airspace, gather valuable intelligence, and return to base before enemy defenses could react. The development of specialized reconnaissance aircraft, such as the Lockheed U-2 and the SR-71 Blackbird, revolutionized aerial intelligence gathering. These aircraft pushed the boundaries of speed and altitude, flying at the edge of the atmosphere and reaching speeds in excess of Mach 3. Their high-resolution cameras and sophisticated sensors provided invaluable information on enemy activities, contributing significantly to strategic decision-making.
Legacy of the Mach Masters. The pioneers of the jet age the engineers, test pilots, and combat aviators who broke the sound barrier and ushered in a new era of military aviation, left an enduring legacy. Their daring feats and technological innovations transformed the skies forever. The quest for speed continues to this day, with modern fighter jets capable of reaching speeds well beyond Mach 2. The lessons learned from the early days of jet aviation continue to inform the design and development of cutting-edge military aircraft. The impact of these advancements extends beyond the military realm. Commercial air travel has also benefited greatly from the jet engine, shrinking distances and connecting people around the world like never before. The Mach Masters of the early jet age forever altered our relationship with the sky, leaving an indelible mark on aviation history and shaping the world we live in today.